Hi again. Welcome to my YouTube channel. My name is Matthew Kimoso. In my last videos, I was dealing with first angle and third angle orthographic projections. That was the conversion of pictorial drawings into orthographic projections. That is from 3D to 2D views. In today's lesson, we shall be converting from orthographic projections to pictorial drawings. And in this case, I have set a question for the purpose of conversion. The question here says, the figure below shows three views of an object drawn in first angle orthographic projection. Draw the object in isometric projection, making x the lowest point. So we'll make x the lowest point. So my x is that corner. Now, this is conversion of orthographic to isometric. And we know that isometric is a type of pictorial drawings. These pictorial drawings are two. One is isometric and the second one is oblique. And in oblique we have oblique cavalier and oblique cabinet. But for this question we are dealing with isometric projection. Now that we know that this is in orthographic projection because of the views, we have three views, and looking at this, we have this as the plan, we have this as the front elevation, and we have this as the hand elevation. Now I will use two sets of pens. I will use the red pen for construction lines, then this dark pen for outlines. And remember, outlines is our solution. So whenever I use this pen, it will show that the solution is now complete. So I will follow up the lines by using this pen. Now let us have this one so that we can make an answer. Now, in orthographic projections, we know that a line represents two faces. This line, any line that is clear, the outline represents two faces. So this one is a corner line and it is visible. Any broken line indicated in orthographic projection is an hidden outline. So the broken line will represent hidden lines. And in this case, we don't have any broken line, we have outlines only. So it means we don't have anything hidden on any face. So we will start by making the isometric axis. So in this one, I will make it very simple. So I will make an horizontal line, and then I will mark a starting point. So I'll project 90. We know isometric projection is a drawing which has been elevated at an angle of 30 on two sides. So we'll have 90, we'll have 30, and we'll have 30. So this is what will happen. I'll produce my construction lines to make the isometric axis. So I know that if they want this x, the lowest point, in this isometric axis, the lowest point is at this point. As you move up this way, you go higher because of the angle, because of this angle 30. So the angle here is 30, 30. Then this one is 120. Now, they need this corner to enter into this point. So this means x is the lowest point and that x is this point. Now we want to know how does these drawings come up. We will assemble the plan, the front elevation and the end elevation to bring up a block. So we'll bring up a block of which that block, if we complete it and we try to convert it back, it must give us these elevations or the views. Now I will make a box. You will have to start by making something like a box on this of the maximum length, maximum width and maximum height. So we have our 110 will enter into this point. So I will make this to be 110. Then I will make the height. The height is 75. I will pick 75, then mark. Then on this side, this is where the end elevation will be. So we will take the end elevation. We have 35, a partition of 35, 35. So that is 70. So I will mark 70 here and this side 110. So I will mark using my pair of compass. So let me pick my 110 and half on this side. I'll have on this side 70. So this is the end elevation. The height is 75. So I'll mark 75 on this height. Now when you have these 3 points, you can do some arcs so that you can acquire the corners and finally you get the faces. So maybe I'll mark this. I'll take this and mark here. Then I will mark the height, pick the height and mark there. Then I want to cut that arc so that I get my point. So just pick the length, then you mark on that height. So the height is 75, the length of this end elevation is 70. Then I've gotten that point. Maybe I will join. Let me join. So join this end and this one, this end. Now I have that. Now I want to have the same. Now remember I took this and I marked there. So I want the height so that I can have a uniform height. So I'll mark this here up, then mark. Then I'll have this line. All these are construction lines. There is no solution. I'm trying to come up with this required solution. Now I want to make that corner. So remember a box has 4 faces, vertical faces, 1, 2. We have the other side 4. Then we have 3, then 4. Then we have the top as 5. The other one is like the base, so it's sitting maybe on a ground. So we are not able to draw the below one, but we can put an imaginary lines, that is construction lines, so that we can relate the views in this. So let me mark the corner. So I'll mark this corner. I'll locate this corner. So I have this side. Then I have this side. Joining it. So I've gotten that. So I have my box. This box is 110 by 70 and the height is 75. Now, when we come back now to interpreting, we know that our x now will be available here. But what do we know from the front elevation? So our front elevation here clearly shows that there is a surface, a uniform surface of a height of 75 minus 55, you get 20. So this height is 20. Now, I can do that height of 20 all the way down. Since Since again the head elevation is also clear, so this one and this one is clear on both sides. So it is 20, then 20. So I'll mark 20, 20. So I'll mark 20. I'll mark 20. So take 20 from your scale and mark. Now I want to assume that this surface is clear all the way around before adding the heights. So I'll make this very simple. Now I have this surface. Now this one cannot be a 3D now. I will have to make the corner for this level, height of 20, I will make as another surface at the top. So I'll make another line going that way so that I have the top surface of that. So that one is by doing an arc. So you can mark this arc, or you can use the set squares to make parallel lines. So you make a line here which is parallel to this line, and this line should be parallel to the line there. So I'll mark this here, then have this, the length of the end elevation, then mark here. So I've gotten my points here. So I will do a construction line also. Then I will do this construction line here. So I've gotten the surface. So this surface, remember I said this line has two surfaces. Now this line is this line. Now we have a surface running beneath this surface. So we have this surface up, and then we have the down surface going there, but it is sitting on a surface. So we cannot draw that because it's not feasible. Now we have this one. You look at this line here, it is this one. And now you can see that this line represents two surfaces. It represents this one and this one. So we have two surfaces. So this one is running this way. Since the end elevation is telling us that the surface is also clear. So we do that. Now we have this surface clear, so I'm done with this and this one. Now, when you come to the plan, this thing is not clear from the plan. We have an object here, and we have a clear object here. So this clear object, remember, it is this one. When you go back to my videos, I clearly stated the first angle and third angle. How do these surfaces refer to each other? So it has a relationship. So this one must align. Remember, the length 110 aligns with the front elevation 110. So the plan and the front elevation must align. Now we have this 120. So this 20 is uniform at the top. So it is running along 70. And here we have our 70. So it is running along 70. So what I will do, I will mark the maximum heights here. So because I know it is running along the width, I will just mark 20, 20. So this one is 20. So I will mark 20 from here. So let me pick this 20 here. And then I will mark here 20. Then I will mark here 20. Then on this side 20. Also, we have this imaginary, the construction line here. I will mark 20. Now that is where our surface is falling. So I will do this line here. Mark this one, get that point. Then I will have this on this point. Now we drop this side here, then I will join this on this side. Now you realize now we have gotten something. We have this block now of that block is this one, and it's running 70. So it's running clearly on 70 on the other side. Now we have this. Now I think this one is not there. This one should be that. That one is clear. So this is a clear surface. Now we have this one now. So this line indicates that this thing is not running. It is not moving this distance 70. So here it has been shown that it is only 35. So it is moving a half of 70. So a half of 70. So you will pick 35. Then you can mark here 35. So the size of this thing, it is inside. So remember here we have a space here. So that space is 10. So you'll have to take out 10. So you can take out 10, and this also you take out 10. Then from here up, take out 10. Then now from here again, you take out 10. Then now you can join, or again, you can have the same size of this 20. Then you now mark what we are supposed to do. So that is it. Then here also, but I will use imaginary lines, start these construction lines. Then let me mark now this one. And then we have that. Then I will join this from here, then this one from here. Then this side join. Now assuming this thing was taking to 70, now I've drawn up to 70, but I will cut. So I'll have to cut the 35. So I'll pick 35 from my ruler, then I will mark 35, then 35. Then here 35. Now I want to make another line there so that I can have parallel lines. So join this down. Then I can mark 35 to cut the surface. So 35 is here and here, so that is okay. So 35 there. So I have my surface now, so I can join this, and then I can join that, then this one, this, then I'll join this. Up to there, we can now trace our solution. We can now trace our solution. We can trace our solution now. So we have this clear surface moving on this side. So it is this side and this side. So we can do a clear outline there. So we have this. Then we have this. Then we have this one. So we have this as a full, this one is full, because we have a clear surface here. So this one is full. And then take this, going this way. So this one now is you give the clear outlines to make your solution. Now, you see now we have this a half block. So this one, this is a half. So I will do a half here. That is half of 70. Then make this up. Make this up. That up. Then this one. And doing this here. Then this one is coming down. Now we have this line coming down here, but it will disappear from this side since this one is a block. So we cannot see the other line running down due to our nature of the drawing. So we do this up to that point. So this line running, this one could have intersected with this line. So now it's not intersecting because this block is making it invisible. So we have that. So and that is the answer. So we have surfaces. So the dark lines is the solution. So we have a surface. Yeah. So we have this surface. Then we have this surface. Now this surface will bring a line here. So you realize that we have a line here due to the face. So this line is brought here. And this one is clear. Now when we come to the end elevation, we shall see two faces. This face, and you realize now this face is clear, but when you are looking at this surface, this face will make you not to see the whole face, so it will cut and give you just a half. That's why we are seeing a half and a half. So this one is a half, and then we have a half side, because this one is like it's flashing with this one, so it will delete the other half and bring this one. So that is it. When you go to the plan, we'll have this surface. It's clear we have this surface. Now we have this surface, and then this one. Then this one from the top is this one. You can do your dimensions. You can do your dimensions now. And you have this. So this one. So this is extension lines. You just extend from the source. Extend from the source. So extend from the source and do the dimensions. So we know from here to there is 110. So we know that is 110. Now we have this as 20. So you can use a construction line. So these lines are construction lines. So you can make that, and you can do it this one here. Because you have the space. This was 20. This was 20. We have that. Now we have here. We have here. So this one is 70. So you will mark here 70. So here you will mark 70. We have the heights. So you can do from here. You have this height. You have this height as 20. Then we have the remaining one, so we can give a measurement here. So the measuring is very easy. You can just do it very fast. You can do it very fast. So this height overall was 75. So I will do 75 here. So you'll dimension anything that is required, anything that gives an information, you must. So I have this here. Can do this here. Can have this one as 10. So this one is falling here. So I'll do 10. I'll do 10. Yep. So you can do this a half. You can show this a half. You can show this a half here. You can show this a half. I'm giving it at this point. So if I show this side, and I give 35, so I'll give it 35 here. So let me use this one. So this one is 35. So I think up to there, we have seen that converting from orthographic to pictorial. We have known that a line signifies that there is a corner face. So there is two faces meeting, it becomes an outline. So if you convert this drawing now back, you assume that you don't have this one and you want to convert this one into orthographic projection, you must get these ones. And that is how you convert this one to this, and then vice versa. From there, I think we've come to the end of our lesson. For these more videos, you can subscribe, share, and ring the bell so that you can acquire more videos and also get real updates. Thank you and bye.